In this video, we'll learn about type checking props and how it can help you debug data type related issues during development. Let's get started. In the last video, we discovered a lot of interesting facts about props and how they can be used to accept data for consumption from a parent component. Props let you access all kinds of data such as strings, numbers, objects, arrays, functions, and a lot more. Since a prop is just a conduit, it ultimately feeds to the component's internal logic, which has to process and consume this incoming data. This means that you have to be extra cautious about the type of data that a prop receives. For instance, a prop that must receive an array of items cannot receive a string. Likewise, a prop that must expect a function cannot receive a number. Therefore, it becomes important to type check and validate data that flows in through a prop. React offers the PropTypes package that exports a ton of validators for all types of data. These validators will throw appropriate warnings in the console whenever a prop gets an incompatible type of data. But before we see how prop validation can be done, it is critically important to note that these validators will only issue warnings in development. Once you produce a production build, there won't be any warnings shown because validation code is removed during the optimization phase. Now, the best way to understand how props can be type checked is by an example. Go ahead, download and extract the project for this video from the link given on the screen. Then, as always, install dependencies and kickstart the development server. What we have here is a component named app which renders a div that we'll use as our canvas. We will use this as a test bed to play with 3 components that I've imported here already. I also have the browser console open because this is where we'll see our errors and warnings. Each of these components have props that have specific requirements in order to function correctly. Let's begin by rendering an instance of the notification component. This component requires you to implement a prop named messages, which takes in an array of messages like so. As you can see, it renders an unordered list of messages. Simple. But what if we pass a string instead of an array? Naturally, the component would fail to iterate over an array it expects and fail. The errors that you see in the console do not clearly describe the problem. While this is one component, imagine something like this occurring in a huge hierarchy of components. The notification component itself simply loops over the messages prop and renders list item tags. Let's implement type checking here so we get better warnings. First up, I'll import the PropTypes package which exports validators that we'll use in our code. Then I'll set notification.PropTypes to an object where we'll describe props and their validators. Since we have just one prop, we'll set messages to PropTypes.array. If you now observe the very first warning in our browser console, it reads invalid prop messages of type string supplied to notification, expected array. This is way better because we know which component is producing the error and why we are getting the error. This way we can fix the error and things go back to normal. Let's now play with the numbered buttons component. This component simply renders instances of the button element based on the num prop. So setting this to 5 renders 5 numbered buttons. Setting this to 10 renders 10 numbered buttons. But if I set this to a string, the component doesn't throw an error but fails to render anything on the UI. In this case, the component uses a while loop internally to push button instances into an array which is then rendered on the UI. Since the array is initialized first, the code doesn't produce an error as such. Such instances are even more difficult to debug since we actually don't see any errors, and it's impossible to predict why this is happening. Let's implement PropTypes here. Once again, we'll import the validators from PropTypes first and then we'll set the num prop type to use the number validator like so. This time I do get a warning which clearly describes the problem to us. This is also critically useful in situations where we pass a number as a string. This will render all right because JavaScript is pretty quirky when it comes to handling numbers as strings. But technically this is a flaw and we shouldn't be passing strings to a prop which requires numbers. So while the component renders, we still see the warning in place. Pretty useful, won't you say? The last component that we'll try in this project is student card. This component requires a prop named student to be set to an object with name as string, ID as number, active as boolean, and courses as an array. So while this is one single prop, it requires an object of a specific shape. If this object has flaws, for instance the name property is absent, then the component renders incorrectly but doesn't produce any warnings or errors. On the other hand, if courses is not an array, then the component fails with errors because it was expecting an array. In the student card component, we'll once again begin by importing the PropTypes package. Then we'll set the student prop to PropTypes.shape, which lets you describe a shape to the object that we are expecting here. So name must be set to a string, and we'll also append the is required option, which ensures you get a warning if this specific property is absent. Likewise, ID should be a number and required. Active should be of the type bool, since it will either be true or false. And finally, courses should be an array. Now our first warning is that the name property is required but undefined, so let's fix that. Our second warning is that courses should be an array and not a string. We'll fix this too. And our component renders successfully at the end. Meaningful warnings help you debug your code faster and fix problems that are not left to guesswork. With the validators from the PropTypes package, you can make your reusable components throw warnings that make sense and guide the developer towards using the component correctly. Since props are a way to provide data and configuration to a prop, the importance of validating props in production becomes all the more important. Besides the validators you saw, there are several other types that the PropTypes package provides. For instance, if your component expects another React component, then you can use the element type of validator. You also have instances where the value of a prop could belong to more than one type. In such cases, we can use the one-of-type validator and provide options as shown here. You can also specify arrays of specific types. For instance, in the examples we saw, the notification component's validator can also be written like this, where we are specifically asking for arrays of strings. And if your prop accepts data of all renderable types, then you can use the node validator. Besides the built-in types, React also allows you to define custom validators. For instance, here we have a custom validator added to our student card component which validates email addresses. If the incoming string is not formatted as an email address, you will get a warning on the console. As you have seen in this video, type checking props can help you avoid headaches when building large UIs and applications. Using the PropTypes package is extremely simple, and you can extend its capabilities by writing your own validators.